Electric motors are made up of two main components, one stationary, called the stator, the other a rotor that moves inside the stator. The stator has multiple wire coils. Running electricity through them creates a concentrated magnetic field that turns the rotor, creating mechanical power. The stator is lined with slots, each of which holds a copper coil. The more powerful the motor, the bigger the stator and the larger the slots. The first step is to line the slots with insulation. This insulation will keep the voltage confined to the coils. The coils are made from several copper wires wound together by programmable machines. The bigger the motor, the more wires per coil. In this motor, each coil consists of 13 strands of copper wire. Now workers tie the coils. This prevents the wires from unraveling while being inserted into the stator slots. Workers cap each coil with fiberglass insulation. Then they insulate the portion of the coil left outside the slots with fiberglass sheets. Then they insert fiberglass wedges to lock the coils inside the slots. Once all the coils are inserted and insulated, workers begin preparing the connection. They slip an acrylic insulation sleeve over both ends of each coil. 13 coils, 26 ends. Then they group these insulated wires into large power cables. The number of wires per cable varies according to the speed and voltage of the motor. They solder the grouped wires together, then insulate the cables. They tuck some inside the stator and leave others accessible to be attached to a power source when the motor's installed. Now, using a cord made of heat and chemical-resistant polyester, they bind the coils tightly to ensure they won't move when the motor spins. This unit of bound coils is known as the stator coil. They now submerge the stator in a polyester-based varnish and vacuum it right through. This thorough penetration makes the stator coil moisture-resistant. Then they put the stator into an oven for 6 hours at 135 degrees Celsius. The varnish hardens, making the stator coil rigid. Now they have to balance the rotor. If it's off kilter, the motor will vibrate, hampering performance. They balance it the same way a mechanic balances car tires, only with 100 times greater precision. Now they slowly slide the rotor into the stator, careful not to damage the stator coil. The rotor will turn on steel bearings. They heat these bearings to expand them so they'll install easily. Then they blow on cold air to shrink them to a tight fit. It's the same process with the motor's back cover. Now they heat the fan and install it over the back cover. The fan's job is to cool the running motor so that it doesn't overheat and break down. They cover the fan with a safety guard. Then install a cover on the front of the motor as well. They run the finished motor through various tests to assess, among other things, insulation strength and performance. These industrial motors are designed for use in factories, for running machinery such as conveyor belts, pumps, fans, and compressors.